All right, welcome to a geometry open house. I'm the teacher. So first of all, there's a brief introduction of myself. My name is Lena Zhao. I graduated from University of Kansas with a PhD degree in chemical engineering, and I also have a master degree in mathematics. I actually also have a master degree in chemistry, but I didn't list it here. All right. So I was teaching geometry at Clements High School last year. And before joining Clements High School, I worked as a senior process engineer in research in chemical industry. So in addition to teaching the Clements, I also taught calculus at University of Kansas from 2006 to 2009. And I also taught chemistry for students, tutoring them. For this course, it's an online course, so you can find this information on Momentum Learning website. It's our class time is Thursday 6 to 8, and the class is going to start at September 15th and ended up as December 8th. And there's no class in November 24 in observance of the Thanksgiving. We recommend that you already finish Algebra 1 before you take the geometry, but it's not really a big deal. That's if you are taking the Algebra 1 right now, you still can take the geometry. So that's the basic information of this course. Next, how to register. So when you register, so you can go to the Momentum Learning website, and then you go to 2022 fall, and you can see there's on the drop menu, you can see the online. So you choose online, and you can find the school math. So this one is the geometry, all right? And then click the register now, you can register. Brief description of this class. For the geometry, that's the most of the students that you already took some, you already learned some geometry since the elementary school. For the students, either from the grade in 7th to 10th, that we recommend you take this course. So you already learned something about geometry. You learn some there's a square and the triangles like that, right? So for this course, we're going to take a deeper dive of the geometry. This we'll split it into the 2 semester, the fall semester, and next is 2023 spring semester. The course for this course, because it's an online course, so we'll need you have a laptop and or a tablet, and also need you to have a notebook ready during the before the class, and also we'll ask you to have a four function calculators. So in somewhere when we learn the trigonometry, so we recommend that's the fancy the TI Inspire calculators, but not all the time. So and here I would add a calculator. Okay, a calculator. We'll do some calculations. All right. Any questions for me so far? All right. This information can be found on the Momentum Learning website. So if you click the course name, so it will direct you to this information, the detailed information, the topics, homework, and class policies. So for topics, that's the full semester we're going to cover. So we're going to cover the foundations for geometry. Right? We'll start with the points, lines, and the planes, and we'll teach how to calculate the distance and the midpoints and angles like that. And then we're going to talk about the reasonings and the proofs. So so I probably will switch this to, I'll probably start start from the reasoning and proof, and then goes to the geometry. Oh, I see that's the one question is that my son is taking geometry at school this year. Is the class taught faster than the school piece or not? So to be clear, to the answer to your question is that we're not going to faster. So pretty much the same the same pace as a school. So we can adjust as see how the students doing. If they're doing great, we'll probably go faster or the deeper. So did I answer your question? Okay, all right. All right, and this reasoning and proofs is pretty new to the students who hasn't taken geometry before. So we're going to learn what's the conditionals and what's the hypothesis or the conclusions like that. All right, so this is a pretty important because the difference between the geometry and the algebra is that we'll do more proof problems for geometry than the algebra. Okay. I split it into two parts. Oh, okay, and then we're going to learn the parallel line and the perpendicular line. So I think the students has already learned this. We'll go to next page. All right, so and this is the that's a continuous topic of the for fall semester. And then we're going to learn the triangles. All right, so this part we're going to learn how to prove the triangles. And we're going to learn the difference, the triangle congruencies and similarities. So it's the students are likely very confused at this part. All right, and then we'll go back, and the spring will be the similar triangles. All right, so I probably will combine I'll put the congruent triangles and the similar triangles in the same semester. I won't split them up. Okay. And the polygons and the quadrilaterals, and then the right triangles and the trigonometry. Here, the trigonometry, when we learn the trigonometry, so it needs students to have a better fancy TS-Bayer calculator. So we're going to learn the Pythagorean theorem. So the students has already learned the Pythagorean theorem, and we're going to learn the trigonometry is new to students. The trigonometry, but it's pretty simple. It sounds really scary, but it's pretty simple. And then continue. That's a continuous of the spring. So, and we're going to learn the transformations. So the students are easily to get confused here, but it's important because we also apply the transformations to algebra 1, algebra 2, and the circles, and volume and the surface, and the 3D figures. So that's the end up of the. I also will add up. So it's not in here yet. But I'll also add up the probabilities. That's the last chapter. That's the last unit for this course. We're going to add some the probabilities. But anyway, for the circles, volume and the surface for this part. So so actually it's not difficult. That's just a lot of formulas. So we're going to provide the formula sheets. And the students are allowed to use the formula sheets when they take the test and the quiz. Any questions for me? All right. So if there's no questions, so we'll continue for the homework. That's the homework. We'll assign homework weekly. So it will be posted as a PDF. And then we'll post the answers for all the homeworks. So the students are expected to complete and check the homework by themselves. All right. So, and I'll take a look of all the students' work, and so I probably will pick up a few homework problems as a warm up at the beginning of the class. All right. So. And that's the class policy. So regular attendance is not expected, but it's essential to your students' success, to your class. So if you have any the other things to, you need to skip a class, you need to miss class, that's okay. So you can let me know, and we'll take the record for all the classes, so you can look at the video. But finish your homework is very important before you go to the next class. Okay. So if you really have anything, you travel, you got sick, or you couldn't take the class, so please let me know in advance. All right, any questions so far? Okay, so that's all about the introduction of the brief description of this course. So for the details, so you can go to this website. So it can provide, if you have any questions, you can go to the website, and if you have further questions that the website couldn't answer you, so please contact Momentum. All right. Okay, so for this open house tryout class, so I'm going to introduce the geometry. So the first, well, the field concept, that's where we're going to start this course, all right? So we're going to learn the point, line, and the plane first. So for the class, I'm going to list out the key concepts we're going to learn, right? Just like this. So the undefined terms, so like the point. So the point is just an indicator of the location. So it does not have a size, all right? So you can say that the point A is just like that. It's just to indicate that this location, all right? So you couldn't, if I draw another one, the point B here, so you couldn't say that's point A is smaller than point B. You can also see their location, right? So and for this and for the points, we normally use a capital letter to represent a point. We call point A, point B, point C, like that, right? And a line is represented by it's just a straight path, all right? So this has no endpoints, okay? So it's a line. When we talk about a line, you can think of that this line is going to two directions infinitely, right? So it would end up. So the line has no length, all right? Has no length. So because it can go this way infinitely, okay? Go this way infinitely. There's no thickness, right? So there's no thickness. So for the notation, we normally use the 2 points. Okay, we use the 2 points on the line to name a line. So just like that, and we use the 2 direction arrow on top to represent it's a line. Okay. So for the geometry, this notation, that's very important. Okay, I'm going to emphasize a lot in the class. So because the line has no direction, right? So if you say that line AB and line BA, okay, you are actually referring the same line, right? So that's the one way that we use the 2 different points on the line to name this line. And we also can use a little lowercase letter like this L. We can say line L, right? So we have 2 different ways we can name a line. Okay. And a plane, you can think of a surface, right? So if you say the plane, you can think of the surface. And pretty much similar to the line that when you think about a plane, so the plane can extend it, okay, endlessly, okay? It has no borders. It has no borders. So extend this way, and this way, so infinitely. And it has no thickness. So, and again, that's the name of the plane is important. So we normally use the 3 different letters, okay? And these 3 points, I'm sorry, that we use the 3 different points. And these 3 points needs to be nonlinear, okay? They couldn't lie on the same line. And then we use these 3 letters to name this plane. So we can name the plane ABC. And again, there's no, they have no, the order doesn't matter. You can name as a plane CBA, okay, BAC. They are referring the same plane. So, and at least for the plane, you need at least 3 points, different points, okay. And the other way that we use only the 1 capital letter P, okay. So, but it's not very normal because it's going to confused with the points. So we recommended to use the 3 different points on the plane to name the plane. Okay, so any questions? All right, so now you see that's why we call the points, line and plane as the undefined terms. So because we emphasize that the plane was at no size, right? And the line has no thickness. And the plane has no thickness, has no borderline. So it has this kind of features. So we call it undefined terms. So for points, line, and plane, so the most important thing that I want you to know is how to name. Okay, how to name the notation of the points, line, and plane. Okay, don't get confused. Okay. Any questions? All right, and now so we just learned that the line. We say that when you draw the line, you need to draw this arrows in these two directions, right? So excuse me. Now we learn the if you take only part of this line, so they form a segment. Okay, so you see this A and B as the endpoint. Excuse me. So in this case, we call this as a segment, all right? And this A and B is the endpoints of this segment. So, and again, that we name this as we name a segment by the 2 endpoints, all right? So look at the notation, all right? Here is the part of the segment. There's no pay attention to the difference between the notation of the line. Okay, you see it has arrows here, but the segment does not have. Okay, excuse me. So and again, that's so this segment has no directions, right? So you say segment AB and segment BA. You are talking about the same segment, all right? So you are talking about the same segment. And look at this line, right? So if I take only this part, I use A at the endpoint and only take this part. So that forms we call the ray, right? You see A is endpoint. So for ray, actually it has the 2 features. It has endpoint and it has a directions. So I would like to emphasize a lot on that when you name the ray, you always start it with the endpoint. Okay, you start it with the endpoint, you see A, and you use another different points on this ray. Okay, and you see that there's only one direction has an arrow. Right? Okay, so for the notation of the ray, pay very much attention. You always start it with an endpoint. Okay, so if you say that the ray AB, you know A is the endpoint, okay, and B is another point, a different point on the ray, okay. So the order of your name, of your notation, indicating the direction. If you say the ray AB, you know A is the endpoint, it goes this way, okay. So this different than the line, right? The line that you say line AB, line BA, they are actually the same, okay, and it's the same. But the ray has a direction, okay. Pay very much attention to here, okay. So the ray has a direction, okay. All right. So now you look at here. All right. So if you use C as the endpoint, okay, so you just look at this part. You have the ray CB, right? And then you look at this part, the left-hand part. You got a C, the ray CA, right? So you see that these two rays, CB and CA, they share the same endpoint, but they go the opposite directions, right? Excuse me. So in this case, we call this the ray CA, you see go this way, and the ray CB, you see go this way. So they form the straight line, and they share the same endpoint. So in this case, we call the ray CA and the ray CB, they are opposite. Okay, they are opposite rays. Okay, all right. So you see that's this segment ray and opposite rays, we call the defined terms, right? So why we call them defined terms? And you see this three one, we call them the undefined terms. Okay, so compared to these three concepts, you see for the segment, we actually have the same length. We have the length for this segment, right? So you see that if AB is here, if I draw another one, the CD, you can tell that the length of the CD is longer than AB, right? And the ray has the directions, right? So that's why we call this three concepts as a defined terms. All right. So you need to understand for this one, for this six concepts, you need how to name it, okay? And you need to understand the difference, and you need to know that these three are undefined terms and these three are defined terms. Make sense here? All right, okay. Any question for me? Okay, all right. If there's no questions, so we're going to. All right, let's do a few problems, okay? Let's do a few problems. So, all right, so you see that this, the yellow plane is a plane, right? All right, and there's a line on this plane, and there's another one passing through, okay? This intersecting with the line and the plane, okay? So don't look at this one. Okay, I'm just give you the answer. Ask you questions. All right. So can you name the plane? Can you name this plane for me? How many different ways can you name this plane, the yellow plane? So recall that we can name the plane by three different points on this plane, and this plane is to nonlinear, right? They need to, they couldn't lie on the same plane, right? So Can I name this as the plane RVS? Can I? Right. Okay. So RVS, you see they're not on the same plane, and these three are different points on this plane. All right. Can I name RQV? Can I name this plane as the plane RQV? Can I do that? Let me see. Okay, sorry. Let me see. All right. Okay, you can answer. You can put your answer in chat. All right. So all right. All right. And you see there's a capital P here. All right. So that's it. You can name the plane P as well. Okay. Now let me ask a question. All right. Can I name this plane as the plane QRS or plane SQR? Can I do that? Come on, come on. Think about it. Can I name this plane as a plane RQS? Let me see. Okay, great. Good job. All right. So why I couldn't name this RQS? You said that's just 3 different points on the plane. Why I couldn't name as a plane RQS? Because it's on the same line, right? So yes, very good job. Okay, very good job. All right. So that's cause the so we couldn't name RQS or SQR because there's 3 points on the same line, right? All right. Okay. So what's the can I name the is there a different way to name the line NQ? There's a line NQ. I can see. All right. So is there any other way to name the line NQ? Let me see. Is there any answers? Right. You can name as NT, right? Or QN. Okay. They're representing the same line. All right. And you see there's a little M. Actually, you can say that's you can name as this line M. Okay. They're the same, right? All right. Another question. So collinear. So we say that's the QRS. Okay. So they lay on the same line. So we call as a collinear. QRS collinear. So do you find the other 3 points? They're also collinear. Let me see. All right. Any other 3 points also collinear? Collinear means they're on the same line. Okay, they're on the same line. All right. Very good. Very good. You can see that T, Q, and they're on the same line, right? So they are collinear. All right. Very good. All right. So if they're on the same plane, so we call coplanar, right? We call the coplanar. Okay. So so you see that Q, R, S, they are collinear, right? And they are also on the same plane. So we are also called a coplanar. Okay. So you see Q, R, S, and V. All right. And the V is not on the same line with RQS, but they're on the same plane. So we call the coplanar. Make sense here? Okay, very good. Very good. Okay, very good. Okay. Oh, sorry. All right, let's look at this. All right, let me ask another question. All right, let me ask another question. It's our points N, V, Q, S. Are they coplanar? Let me see. No, very good. Okay, no, you see that's the R, Q is this on this plane, and N is actually not on this plane. So they are not coplanar. Okay, very good. Okay. Very good job. All right. This ray, okay, so let me ask a question. All right. Let's stop talking about the ray, right? So can you name this line for me? Okay, how many ways you can name this line for me? Let's see if any answers. So we say that how do we name a line? Use the two different points on this line, right? So can I say line DE? All right, yes, right? Okay, let me see. Yes, very good, very good. Okay, you can use the any combination of the three letters, right? Okay, line DE, line DF, all right, and line ED, line FD, line FE. Okay, very good. So because the line has no directions, okay, you only need two different points on this line. Okay, very nice. Okay, all right. How about the segment? Can you name two? Can you name? Let me ask it in this way. How many different segments in this line you can find? Different segments. How many? Segment has a length, right? Has a two endpoints. So that's the yes. Okay, very nice. Okay, very nice. That's three, right? So you can see DE, okay, and you can have DF, you can have EF, all right? Very good. Okay, very good. Okay. Oh, can I say segment ED? Can I say that? All right. Yes, yes. Segment ED is the same as segment DE, okay? Because this has no direction. This only has two endpoints, all right? So the segment has endpoints and has lengths. Okay, very good. Okay. All right, now let's talk about ray. All right, can you name the two rays for me? Rays, when you think about rays, that's part of the line, right? It has the segment, and it has directions, okay? Okay. So EF, yes, very good. All right, and ED, okay? All right. Can I name the segment DF? Sorry, ray DF. Yes. Can I name the segment FD? Yes. It's the ray FD and the ray FE. Are they the same? Are they the same rays? Think about it. For the ray, that's only you determine are they the same. You only look at the endpoints and the direction, right? If they have the same direction, if they have the same the same endpoints, and they are the same ray, right? So you see that F, D, F, E, they actually have the same endpoint and the same direction, right? So they are representing the same ray. Okay. So if once your endpoint and the direction is determined, so you can use any other points on this ray to name that. Okay, they're representing the same ray. Okay, very good. Okay, very nice. All right. So far, any questions for me? Okay. All right. I'm going to give you a few true or false. All right. So that's the all right. That's this true or false are going to test that you have a clear understanding of this concept. All right. Okay. So the first one, the ray. Okay, you see that's the one direction, right? One direction. Okay, that's a ray. Okay, so this shows the one direction. That's a ray. DF and FD representing the same ray. DF and FD representing the same ray. True or false? Come on. Think about endpoints. Okay, how do we name the ray, right? So we emphasize this a lot. You have to start with the endpoint. Okay, true or false? Now let me ask this question. So if this if I say the ray DF, so which point is the end point? Come on, come on. Which point is the end point? D, right? So the answer is, okay, the answer is that's, oh, let me see. Oh, very good. Okay, so I already answered all the questions. Very nice. Okay, very nice. Okay. Good job. All right. So this is false. Why? Because the F, the miss end point is D and it goes this direction. And the FD end point is F and it goes this direction. Okay, so the all right, now let me ask this question. Are they opposite rays? Yeah, they do go the opposite directions. Are they opposite rays? Come on. Yes. Why yes? How do we define the opposite rays? Okay, so opposite rays. Yes, opposite rays. They need to have the, yes, opposite directions. And they need to share the same endpoint, okay? All right, so very good, okay? So you see that's the, even though DF and FD, okay, they are opposite directions, but they are not share the same endpoints. You see the endpoints of DF is D, okay? And the endpoint of FD is F. So they are not they are not the opposite directions, right? Okay, very good. Okay. So DE and DF, and yes, we just talk about that. Okay, so DE, DF, okay, the same endpoint, the same direction. So that's true. So how about this one? DF, EF, are they representing the same rays? Because they are have the same direction, but they do not have the same endpoint. Okay, so that's false. So, and you see that you have the double direction error. That means a line. Okay, that's a line. Okay, so we see that the line has no direction. All right, so they are representing the same line. Okay, and DE and DF, okay, they are on the same line. Okay, so any combination of these points, yes, true. So DF and EF representing the same line. Okay, that's true. Okay. All right, makes sense here. So here that it's very easy to confuse with the opposite rays, this concept. Okay, just make sure you understand for the opposite rays, they need to go to different directions and they need to share the same the same endpoint. Okay, if I say that the ray DE, sorry, ray ED, ray EF, then they are the opposite rays. Okay, all right. Now I have one critical thinking question for you. So can you draw the two different rays? Okay, they started from the same endpoint, but they are not the opposite. They are not opposite rays. Can you draw two rays? Okay, they only share the same endpoints, but they are not opposite rays. Can you do that? How do you do that? Any idea? Okay, very easy. Okay, so you see that if you start with the E, EF, and ED, they have the same endpoints and they go the different directions. Okay, so that's the opposite rays. All right, now look at here. Look at my mouse here. So if I start from E and I draw a ray from this direction. So you see that? Okay, so next time we're going to use the whiteboard. Okay, so you can see well. So E, if I draw a line over here, okay, so and you see that's EF and the other, this ray, they share the same endpoint, but they are not opposite rays. Okay, all right, very good. Okay, yes, very good. Okay, very good, Clement. Okay, very nice. Okay. So now you have an idea that how do we start with the geometry, okay? So that's probably the first or the second, the second unit we're going to learn, okay? So any questions so far? All right. So if there's no more questions, so I'm going to close a little bit early today. So and this one, all right. So if you have any questions, all right, so in the future, so you can always reach out to the Momentive office hours. That's a phone support. Okay, that's the number. That's the phone number. And that's the open hours. Okay. Or the quickest way, if so you can always email email this email address. Okay, you can get the faster response. Okay. Once again, so go back to here. Go back to here. So you can go to the Momentum Learning website to check the information of this course, and to enroll. You can go 2022 fall and go online, and then you can choose the school math, and then you can see the geometry. Okay, all right. All right, so if there's no more questions, I would like to close a little early. So thank you very much for joining, and I look forward to seeing you in the class. Okay, all right.